All right, so we're starting section 2 today, which is going to have a little bit of review of what we've already done, but that's kind of what we reviewed last week. We talked about this. We talked about an exponential equation, an exponential function, and so it's the same. It's the same thing. A function is something that passes the vertical line test. If I call the bank, it's only going to give me one amount for my bank account. So it is when the variable is in the exponent. And it's the same thing whether it says to write an equation would be y equals. If it says to write a function, you would do your f of x. Okay, compounded interest is when the interest is increased by a unit of time. Okay, so what that means is some bank accounts, they'll do things quarterly, they might do things daily, they might do things yearly, they might do things monthly. So, and that's by a unit of time. So it's going to be compounded. So if I say that I'm going to compound the interest monthly, I would take the interest and divide it by 12, and I'm going to give you the formula for this. And then I would take it that many times. I'm going to do it 12 times in a year. Okay, an exponential inequality, again, is an inequality, and we're going to deal with those in this unit. An inequality where the variable is in the exponent. Okay, all right, so the first thing we're going to do, ENLF2, so exponential and logarithmic functions, that's the chapter we're on, and this is 2, and it's talking about changing between forms without a calculator. And actually, last chapter we did this, so they're going to be bases that you recognize. And this is actually a review skill. They're going to be harder than what you did in Algebra 1, but this would have been an Algebra 1 problem, this particular problem. So I would have 3 to the x, and I could rewrite 9 as 3 squared. Now, if I couldn't rewrite it as a 3, then that would be a log question, which we're going to get to later in the week. So everything on your homework tonight is going to be things that you can rewrite. So if I do a power to a power, 3 to the x would equal 3 to the 8th. So now that means that since my bases are the same, then I can just look at my exponents and x would equal 8. Now, since it's exponential, I do not have to check because everything works in exponential. You're not going to have extraneous on this part. If it's an exponential problem, it is all real numbers as your domain, so everything works. Okay, so if I look at this one, again, let's go back to this one on this very first one, because some kids, I'm sorry, I didn't mean to make you dizzy, but some kids, like, instead of making the bases be the same with the 3, they like to both make them 9s. Okay, if you make that a 9, then that's going to be 9 to the 1/2. That's what would give you 3. And so then my bases cancel and I get 1/2 x equals 4. So I would divide both sides by 1/2 and my answer is still 8. So I guess I need to make this point on the very first question. You could turn the 9 into a 3 by making it 3 squared. Or you could turn the 3 into the 9 by making it 9 to the 1/2. Which is why I personally will always make mine smaller. So that way I don't have fractions. Okay, so let's take a look at what I'm saying on this one. I'm going to do it both ways, and then from there I'm going to do it my way. Okay, I can rewrite 4 as 2 squared. So now my bases are the same, so I can just look at my exponents. And so this side would be 4x minus 2. So then I would minus 4x and minus 4x, and my answer would be a -2, which is fine. You can put it back up there and check, that's fine. Okay, so now some kids want to make, instead of making the 4 into a 2, they want to make the 2 into a 4, which would be 4 to the 1/2. 4 to the 1/2 is 2. So then this would be 4 to the 2x minus 1. So this side, my bases are the same, so I would have 5/2 x equals 2x minus 1. So I would divide both sides by 5/2, which is the same thing as multiplying by 2/5. So when I multiply by 2/5 on this one, I would get 4/5 x. On this one, I would get minus 2/5. So now I would minus 4/5. I'm trying to make a point. Minus 4/5 x. That I would not work it this way. So it's going to be 1/5 x equals a negative 2/5. And now I would divide by 1/5, which is the same thing as multiplying by 5, and x equals a negative 2. Look at all that work. So please hear me when I say, you can do whatever you want. But if I were you, I would take the bigger one and make it smaller, because then you're not going to have fractions. And look at that. I get the same answer, but the red way is way faster. Okay, so I'm going to say, try this one. I would like you to hit pause. I would like you to try it on your own. See if you can do it. Pause. All right, so when I do this, I would rewrite 64 as 4 cubed. And then that's to the third. So my bases are the same. So my answer is 9. And you can check it by plugging it back in and seeing that both sides match. Okay, I would like you to try this one. Pause. All right, so again, I always make my bigger numbers smaller by saying 3 squared. And in some of your minds, you're saying, but what happens if you can't rewrite it? That's tomorrow. Tonight's homework is all going to be things that you can rewrite. So this would be 2x equals 10x minus 4. So if I minus 10x, I get a negative 8x equals a negative 4. So x equals 1/2. Okay. All right, so now these get a little more confusing. And so like I wanted to make a point above, because I am not working this one two ways, because this one is ugly the other way. I would take the bigger one and I would try to figure out how to turn it into the smaller one. So first off, 3 cubed is 27 and 2 cubed, so I'm going to write this beside. 3 cubed is 27 and 2 cubed is 8. But I need 2/3, not 3/2. So how can I not only make it smaller, but also flip it? Wouldn't this be 2/3 to the negative 3, and then it would be x minus 4? Because if I take it to the negative 3, that would give me the 27/8. So now my bases are the same, and I get 5x plus 1 equals a negative 3x plus 12. So I'm going to add the 3x and get 8x. I'm going to minus the 1 and get 11. And my answer would be 11/8. And you can check this with your calculator by plugging it into both. That is probably what we will do in class. So if you want to do that and pause quick, you can. But that's up to you. You can check your answers. These would all be no calculator, but you can check. The inequalities are the same. So what this whole line is saying, and you can look in the 2 textbook, is if you know 2 to the x is greater than 2 to the 6th, then you know that x has to be greater than 6. That's going to always be true. So it's basically the same thing we're doing. So I would take a look at the larger numbers, which kids are like, but 1/625 is a fraction. But can't I rewrite that as 5 to the negative 4th? So I'd have 5, and then I would have 5 to the negative 4th. I apologize. I messed up on my sign, and I don't want to start over. All right, there we go. So now those are the same. So I would have 3 minus 2x is greater than a negative 4. So I would minus 3, and I would get a negative 2x is greater than a negative 7. And then I would divide, which flips my sign. So x would be less than 7/2. All right. So take a look at that. You don't have to put like a common sense one like we did last chapter. I mean, we're going to when we do logs, but exponentials are all real numbers, so you don't have to worry about something not working. Okay, same thing here. This 243, I can rewrite that, I believe. My head is hurting today. I believe that's 3 to the 5th, but my brain hurts. It's got to be something that works. So it's got to be 3 to the 5th, right? That makes sense, doesn't it? Oh, I hit the wrong button. 3 to the 5th. Yep. Okay, but I'm going to make it a negative 5th to make them equal. So my bases are the same. So I'd have 4 minus 3x is greater than a negative 5. So I would minus the 4 get a negative 9, and divide by negative 3, which flips the signs. So it's less than 3. So you can try something and check it and see if it works if you would like. All right. So I'm going to help you over the weekend. Hopefully you watched the project video. I'm going to help you kind of get started on the project. We're going to kind of do this in pieces. And so I would take out a sheet of paper right now and label it project. That's what I'm doing in the classroom. And so you should have your 2 points. So you should be able to write the equation in exponential form. I'm not asking you to do anything else. I'm going to hand out the rubric on Wednesday. And so on Wednesday, I'll have another project video with the rubric to explain to you all the parts, because on Wednesday, what I'm going to do is show you 2 examples of projects. Okay. And so honestly, I don't know if I'll make a video for that. I might just do that during the beginning of class and you can watch. But anyway, I would make a paper that says project, and you could put practice 1. So what I'm saying is, what if your project in the year 0, it was 6.4, in the year 3, it was 100. So you do know an initial value, right? And you do know a point, an X and a Y, right? I know this is an X and this is a Y. And I know it's growing, and I want to write an exponential function. So it's going to be a 1 plus r. So if I write my 6.4, 1 plus r to the x, I can erase this y and I can make it 100. And I can erase this x and I can make it a 3. So I'm going to take out my calculator and I'm going to solve this thing. So turn it sideways because I'm going to need it sideways. So I'm going to do 100 divided by 6.4. And that equals 15.625. And that's 1 plus r to the third. So I'm going to take it to the cube root or to the 1/3. It doesn't matter. I'm going to take it to the cube root. And I get 1 plus r equals 2.5. So now I don't know why I wrote that there because I'm crazy. All right. So I now know that my 1 plus r is 2.5. So I could write an equation. My equation would be y equals 6.4 to the 2.5 to the x. Because this already, if you want to split it out, wouldn't this be 1 plus 1.5? If you want to, I would take either answer. Some kids want to leave it. Some kids want to split it. Because in the project, it will ask you, what is the growth rate? Well, my growth rate would be 150%. That is my growth rate. And my growth factor, which it doesn't ask, but we might as well talk about it, is 2.5. Okay, so it will ask you in the project, in the rubric, and the paper that I gave to you on Friday has that as one of the questions, like what did you find as the rate? So you will be expected to write one of these 2 equations. Okay, so I would like you to try this one. I'm going to tell you to hit pause. So I have had a couple of projects over the years that actually decayed in value because it was something like, something like a car would decay and then it would grow again. But anyway, so write this one, pause, and then we'll go over it. Pause. All right. So we know y equals 8,000 because that's my initial value. I know this is a 1 minus r to the x because I'm decaying. Okay, so if I plug in what I know 1,000 equals 8,000 to the 1 minus r to the 10th. So I'm going to take 1,000 divided by 8,000, and I get 0.125 equals 1 minus r to the 10th. So I'm going to take that to the 1/10. And I got 0.8123 equals 1 minus r. So again, I can, and I really don't need that in parentheses. I just want to show you something. So I'm saying 1 minus r is that. So now I could write my equation for my project. It would be 8,000. I don't know why I put a decimal point there. It would be 8,000. 1 minus r is 0.8123 to the x. So that would be my equation. So now if I wanted to find my growth rate, my growth factor is easy. It's definitely not growth. Decay, if I wanted to find my decay factor, it's just whatever is in those parentheses, 0.8123. But if I want to find my decay rate, I would have to subtract that from 1, which I'm doing right now, and I get 0.8175. So my decay rate would be 18.75% because you move the decimal 2 places. So you could leave it like that or however you want to do it, but if you have 2 points, if you got your 2 points over the weekend, you should be able to write your equation, which means then a lot of your math is done. Okay? So it says on example 7, this is example 1 in ELF 7. So we have to do the applications, and you're going to have some applications on your homework tonight. It says in the year 2000, the population was this big number. And then it says in the year 2007, it was this big number. Write an exponential function. So they want me to write an exponential function. Exponential function that could be used to model the situation. So it's kind of like the project. I know the initial value is 1321045. That's what it initially was. It's growing. So it's going to be times 1 plus r, and I'm doing this in 7 years. And my new population is 1512986. So again, this is like the project. So when I said that the project is like my big time extra credit, it really isn't that bad. 986 divided by 1321045. And I got 1.14529, blah, 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 equals 1 plus r to the 7th. So I'm going to take that to the 1/7, and I got 1.0196. That's what 1 plus r is. So my equation would be y equals 1321045, parentheses 1.0196 to the x. That's example 1, ELF 7. Now, example 1 continued. Predict the population in 2013. So if I come back up to my equation, and this is what's going to happen on your homework, it's going to ask you to just keep using the same problem. So this would be, it wants 2013. So I'm basically going to just plug 13 into that equation. 1.0196 to the 13th. And then you're going to times that answer 132. I'm using my phone. So I have to do it in steps. If you are at your house, you probably could just type it all in, I'm guessing. So you'd have 1,700,221. Because we're talking about people, it was actually 220.9. So it's just a prediction. I'm just going to round that up. Okay. And then this is the last thing that we're going to talk about, and you really want to get a glance at this. This is this is that compounding thing I was talking about. This is the equation. So my n is the number of times compounding. So if you were going to do something monthly, then you would take the rate and you would divide by 12. But now if you're doing it in a year, you're not doing it once, you're doing it 12 times. So that's going to be your n. If you were doing it daily, that would be 365. If you were doing it minutely, it would be 525,600 minutes, right? It's that song. Anyway, and it was in the musical Rent, but it also was in The Office. So one of the two places you should have heard it. But anyway, I'm not going to ask you to memorize those, but that's what you're doing with these. So let's take a look at an example. An investment pays 5.4% annual interest compounded quarterly. So that means they're doing it for a year, but they're not doing it once in a year. They're doing it 4 times. So if $4,000 is placed in this account, find the balance. So I want to find how much is in it after 8 years. So I'm going to do 4,000, and then I'm going to do 1 plus 0.054 divided by 4. Why am I dividing by 4? Because it says quarterly. And now I'm going to do 4 times 8 because I'm doing it 4 times a year for 8 years. So I really should have brought a calculator in here. So I'm going to put this in, and to the 32nd times 4,000. So I want to round it 2 places because we're talking about money, $6,143.56. So that's what's going to happen when you compound it quarterly. Okay. So the next one is compounded daily. So whenever it asks for daily, we can totally get in an argument over this, but I'm just going to tell you what math people do. Math people always make the assumption, and I know you shouldn't assume, but I'm going to let you, that there are 365 days in a year. So what you're going to do on this, it's $6,000, $6,050 placed in a bank at 4%, 4.6% interest, compounded daily. So you're going to take it to the 3 or divide by 365. So then you are going to do, this would be 365 times 6 because you're doing it 365 days a year. You're doing it every single day. But then what you're doing is you are doing it for 6 years. So you're doing that whole thing, and hopefully I can do this on a phone calculator without too much problems. Are you kidding me? I made one mistake at the very end. 0.046 divided by 365. In the parentheses. Times 6050. Do it right. All right, I got $7,972.84. So hopefully you were able to get that same thing. The nice thing about this, you can just plug that whole thing in your calculator. I can't since I'm on a phone calculator. So please email me if you are having questions or problems or concerns. For the most part, especially during the week, I will email back. I took a couple days off this weekend because I've been working straight through. So I did not check my email basically from Friday night till Sunday afternoon. I needed some time. So I'm checking it now so you can send me emails and I will get back to you. I feel like I've got a better grasp on everything. So I will see you later.